all. It really is.
Yeah. You know, this last unit has gone pretty well. We just need to kind of review.
But I'm exhausted.
Oh, I second that. Oh, Lordy.
Oh, remember how all this started?
I can barely remember how it started. What happened? You know, now that you mention it, that first one was so much fun. Like, just getting that sidewalk chalk out and then being able to talk about like what a radian is, because it's like so obvious and easy, but if you don't understand it, it's hard. But now we all know it's a radius, so piece of cake.
Okay, so then we put it on axes and all of a sudden it became this big unit circle that we could now have coordinates on. And then we saw these special right triangles occur in the circle that we used to then find all the coordinates.
Yeah, you had the 45, 45, 90, and then I used the 30, 60, 90 to do the pi sixths and the pi thirds.
I remember rolling around in the chalk. That was no fun.
Were you a little bit sore that day?
Oh, yes.
Oh, yeah, yeah. Kids, just playing is good exercise. Oh my gosh, remember the 3 bow ties?
Yeah, the one for pi fourths.
Yep.
Then
pi sixths
and then pi thirds,
pi
right?
Thirds. Yeah, yeah, it was all good.
Why did we do all that? What was that even for? Like, what's the importance of using the unit circle?
Well, it's so important because we can use it to find values for sine, cosine, and tangent. And then, of course, we used it to extrapolate and understand the sine curve and the cosine curve. So there's many applications. We haven't even gotten to them all.
Okay, now I want to quiz you. I want to see if you know your coordinates around the unit circle.
Really? Really?
Yes.
Okay. Wow, really? We had to start with tangent of -5 pi 6? Well, that's okay. So I'd want to just draw in my xy axis and then count pi 6. So -1, 6, 2, 6, 3, 6, 4, 6, 5, 6. Boom. Create my reference triangle. That's, of course, coterminal to +7 pi 6. And we see our x coordinate, it's in third quadrant, so -√3/2. Y coordinate, -1/2. Tangent is sine over cosine. Then I do -1/2 divided by -√3/2. Multiply by the reciprocal, and the 2's would divide out. I'm not going to write all that down because I kind of remember that. So then we ended up with 1/√3. We have to rationalize the denominator, multiply by a creative form of 1, and we get +√3/3 because we had negative divided by negative, which is a positive. And that's kind of one of the trickier ones. How about you find a theta, sine theta, when it equals -1/2? But of course that occurs twice, so let's keep it between pi halves and 3 pi halves.
All right, so sine is negative. Let me see. So I only care when I'm only looking when it's between pi halves, which is here, and 3 pi over 2. Okay, and then sine is the y coordinate, right? So I want to look where y is negative, so that's going to be in the third quadrant. So, and then 1/2, that's the short side, right? Like the little, what did you call it? This
Across from the
short leg?
Uh-huh.
Okay, so that's the short leg, so it's like right here. So there's my little -1/2 is the y coordinate, so that would be, what, √3/2 negative for the x, -1/2 for the y. So now I gotta figure out where that is. So if this is pi over 2, then it looks like I'd have to go by 6's, so I'm just gonna count all the way around. 1, 2, 3, 4, 5, 6, 7 pi over 2 is where I end up.
No, you don't. You end up at 7 pi over 6.
Dang it, that's what I meant to say.
I know. This ended up being the same place as my problem. It was just asked a different way.
7 pi over 6. Killed it. All right, let me throw a curveball at you, Peart.
No, you are too tired.
Let's do cosine of 7 pi over 4. But since you don't have to find me theta on this one, I want you to draw me a reference triangle with the sides labeled for that. Go for it.
You got it, because we showed this in the video as well. So 7 pi fourths is right before 2 pi, which is 8 pi fourths. So I'm just going to go right to that spot, connect back to the x-axis with a right triangle, because x marks the spot. And, ooh, my triangle is not looking like a 45, 45, 90, but it doesn't matter so long as I label it correctly. So this side length would be √2/2. This side length is √2/2. But when I describe that coordinate, I have to remember I'm in fourth quadrant. and sine, or the y-coordinate, is negative. So this is at positive root 2 over 2, negative root 2 over 2. So if you had asked me what sine is, negative root 2 over 2, cosine is positive root 2 over 2. And hey, as a bonus, tangent would be negative 1 at 7 pi fourths.
Okay, smarty pants.
All right, next.
What else did we do other than use the unit circle? Because I know that was a lot of what we did, but then that next week, weren't we looking at something else?
Yeah, we did
converting. Oh yeah, no, that was when I was hungry for the waffles and we had to convert. Yeah, so
that was
that
was good timing on your part. Yeah.
So what do I multiply by if I want to convert to degrees?
2 degrees, so we're in radians. Then I'd want to cancel the pi's or cancel the radians, so I'd want to go 180 degrees over pi. What about the other way?
Okay, so I want to convert to radians now?
Yeah.
So from degrees, so I want to cancel the degrees, so I'd want 180 degrees on the bottom.
Right.
So I'd multiply by pi radians over 180 degrees.
Perfect.
All right, throw one at me, Peart.
Okay, let's see if you can convert 140 degrees to radians.
All right.
Keep it exact.
Okay, so I want to convert from degrees to radians. So I'm going to want to multiply by something with degrees on the bottom, so it cancels. So 180 degrees on the bottom, pi radians on the top. Multiply across, I'm going to get 140 pi over 180 because my degrees divide out. So then if I divide that, I mean 14 pi over 18, but that reduces one more time by 2, so 7 pi over 9. But man, am I tired. You should probably check my math there.
Oh, I think you had it right, but maybe somebody else would want to remember how to check it on the calculator. Let's see. I always have my calculator nearby.
Well, that's what you're known for. Whipping that out.
True story. So remember, this was in one of our little hint videos, that all you have to do is type in 140 divided by 180, enter, yucky decimal answer, and then you hit the math button, enter, enter, and sure enough, 7/9 is our fraction.
Okay, Miss Calculator Mania. Let's see you do 0.6 radians to degrees then.
Okay, 0.6 radians. I like how you tried to throw me off a little bit because it's not in terms of pi. That's okay, because 0.6 radians means we went 0.6 of a radius around the circle.
Challenge, challenge. What quadrant do you think 0.6 radians is in?
Ooh, well, it's less than 1 radius, so I think I'm still in first quadrant. I want to go to degrees, so I'm going to simply multiply by 180 degrees divided by pi radians. Sometimes it's helpful to write that radians in so you realize you are dividing those out. Now I have a beautiful calculator problem. Okay, good thing I have my calculator nearby. 0.6 times 180 divided by, and let's use the pi button, not just 3.14, and we get 34.377. So that's an easy one to round to the nearest degree. I'm going to put approximately equal to 34 degrees.
Woo! What else did we do when we did those conversions in units?
Oh.
You want me to bring that up?
Well,
You remember that day?
yeah, you know, I was trying to relax. Yeah.
Yeah, but who has a pie just on hand in a robe?
I don't know. It was just bizarre. Okay. I think that was our arc length lesson.
Yeah, learning how to find an arc length given a radius and a central angle.
I don't think that ended up too hard. I think we should do an example of each, but I want to do the one in radians, okay?
Okay, but wait, remind me of the two formulas before you do that. We had S equals.
Okay, if we're given the central angle in degrees, then we have to find the entire circumference, 2 pi r, and multiply it by the part over whole in degrees.
So that's why you want to do radians then, huh?
Yeah, because what do I do for radians?
S equals R times theta.
Perfect.
Stinker.
Easier.
Okay, fine, you can do that one. What's my radius and central angle?
I think you should have a central angle of 87 degrees and a radius of 2.7 inches.
Okay, so arc length S is circumference times part over whole, right?
Yep.
Of my angle. So S equals, okay, circumference is 2 pi times my radius, so 2.7. Part of the angle that I have is 87 degrees, divided by the whole circle would be 360 degrees. Ugh, I totally see why you gave this one to me.
I know. Do you want to borrow my calculator?
I'm going to make you plug it in. S equals.
I don't need to put
I
in
know
S
you
equals.
don't. 2
2
times pi
times real pi, but pi.
times 2.7.
times 2.7
times 87
times 87
divided by 360.
divided by 360.
Okay, what do you got?
I have 4.09977. What should we round to?
I think the direction said 10th, right?
Yeah, probably.
So 0.09, is gonna round up my 0 to 1. And oh my gosh, I had a degree label, but this wouldn't be degrees. This is arc length, so this is inches.
Nice job, Miss Ryan.
All right, so you promised you were gonna do one.
Yeah. But
So-
I'm doing the radian one, right?
I know, you're just doing a radian one, so let me throw one at you then.
Okay.
Let's see, 2 pi over 7 and a radius of 73.4 centimeters.
All right. Arc length then equals r times theta. So all I have to do is 2 pi sevenths times 73.4, and that is 65.883. Okay, so 65.883. Dot, dot, dot. Okay, so then that rounded to the 10th is going to be 65.9, and you said centimeters. Done.
What do we do after, having that dance party and all that? Oh yeah, then we started graphing sine and cosine, right? That was Wilson debacle.
Yeah.
So we first learned to graph sine, and that's where we had the pattern points. We started at 0, we went high, back to 0, low, back to 0.
Yeah.
And that was one cycle of sine.
And wasn't it cool that it all came from the unit circle?
That's just insane.
I know.
And then we introduced okay, a period's the length of one cycle, the amplitude's half the height from the max to the min.
Right. And then we talked about reflecting. So that wasn't too bad, because if sine is reflected, instead of going high before you go low, then you're going to go low before high.
Yeah, and then we even talked about steps to graphing, like having your period, getting that on the graph, dividing that into 4 parts, and then just plotting your pattern points once you have your amplitude and period on your axes.
It did get a little bit harder, though. Had to do a little bit more thinking.
Especially when we started multiplying things inside with the theta.
Oh, that was crazy.
Like, remember that one you did? It was y equals sine of 2 theta.
Right, right.
And then what'd you figure out about the 2 next to the theta?
Well, the coolest thing was that created this this dilation, this horizontal compression that we have never really had a chance to see before in this class.
And then you'd managed to figure out that it was the reciprocal of whatever was next to theta, right?
Right, exactly.
So we were able to use that then to go back and find the period.
Once we know what b is, it was pretty easy, because you took the original period of sine, 2 pi, and multiplied it by the reciprocal. And that gave you the new period.
Yeah, that was awesome. So let me see if you can write a function then for sine if I tell you some facts. Are you ready?
I'm ready.
All right, so let's see you try to write me an equation. Let's say it's a sine equation, because that's what the video was talking about. So we'll do y equals sine x, or sine theta as our original. And then let's make your amplitude 3. And then let's say your period, let me try to make that a little bit more tricky, pi fifths.
Ooh, okay.
Okay, but wait, a has to be less than 0.
I'm going to go ahead and write the entire equation, just the basic equation. So y equals a sine, we used x here for the variable this time, so I'm going to keep x, bx. So if a is less than 0, I'm talking it's negative. We know the absolute value of a is the amplitude. So right away, the easiest part is that I have -3 for my a. Sine of b theta. Well, now b is the number of cycles between 0 and 2 pi. So if I know the period is pi fifths, it has to equal the original period times my dilation, horizontal dilation, 1 over b. So I have pi fifths equals 2 pi times 1 over b. 2 pi was my original period from sine. I'll go ahead and multiply by b on both sides. Ooh, this is getting interesting. So then I have b times pi fifths equals 2 pi, and I have to solve for b. So then I would multiply by the reciprocal, 5 over pi. The nice thing here is the pi's divide out, and I just end up with b equals 2 times 5, 10. So now I just have to plug the b in, which is 10. There's my final answer. Y equals -3 sine 10x. All right, time for you to do a graph. Equation from a graph. Come on.
All right, so I've got this graph right here. Okay, it starts at 0, 0, so I know it's sine. So it's going to have to be something like y equals a sine of b theta, or x, but since the axis is labeled as theta, I'm going to use theta. That means I've got to find the amplitude, and I've got to find b. B is the number of cycles between 0 and 2 pi, but since I don't have a 2 pi on my graph, I might have to use the period to get it, like Miss Peart just did. So I know the amplitude, okay, half the distance of the height, so that's going to be 3 and 3 would be 6, so half of that's 3. So period I can see on my graph because it's just the length of one cycle. So sine goes, so my one cycle of sine would look like this because it's been reflected. So it looks like my period's going to be 2. So if I know that the period is supposed to be 2 pi times 1 over b, that's what my period is, then I could say, since I know the period's 2, I could set these two things equal to each other. So 2 equals 2 pi times 1 over b, and do exactly like what Miss Peart did before. So multiply both sides by b, get 2b equals 2 pi, because these b's divide out, and then I can just solve for b. So divide by 2 and get b equals pi. Boom! So I got my b, which is here, I got my amplitude, which is here, so now I just need to write my equation as 3 sine of pi theta. Is that looking right? Oh wait, it started at 0 and then went low before it went high. So we know that there was a reflection over the horizontal axis here, so I've got that little negative sign in front of my 3.
You know, Miss Ryan, we learned about cosine as well.
Yeah, and the pattern points for cosine were like just slightly different than sine. What were they?
Well, it started up like a cup and then went down to 0, low, back to 0, high.
Yeah, and so basically everything else was roughly the same. Like the period was still the length of one cycle, so the period of the parent was 2 pi, yeah.
Yep.
Then the amplitude was still half the distance of the height.
A 1.
For the parent. Okay, so what if we started moving around some stuff with cosine?
It's going to work the same as sine, so that's the nice thing.
Okay. All right, so let's see if you can write me a cosine equation kind of like you wrote me the sine equation before then. So let's say, okay, you have a cosine parent function, y equals cosine x.
Okay.
You're going to horizontally stretch it by a factor of 3.
Ooh.
And then you're going to translate it actually to the left, pi over 2 units, and up 5 units.
Okay, wow.
So this is more like from lesson 7.
Yeah, okay, well, we know that the basic equation is the same as sine, just with cosine. So y equals a cosine bx. Doesn't look like there's been any sort of a vertical stretch or compression. But we do have it horizontally stretched by a factor of 3. Now remember, when it's horizontally stretched by a factor of 3, 3 isn't b, it's always the reciprocal. So that meant that b would have had to have been the reciprocal of 3, or 1/3, for it to then be a horizontal stretch by a factor of 3. We'll have y equals, I don't need to write 1 for a, unless you're on the computer answering a question, and we're going to have b is 1/3. Now we have a left-right translation and an up-down. So I'm going to have that 1/3, but I'm going to go ahead and put another parenthesis because then x, if I'm going left, that's actually opposite, inside opposite. So x plus pi halves units. And then up 5, that one I always like because that's easy, plus 5 at the end. What do you think, Miss Ryan?
I think you did pretty good.
Okay. Did that kind of sum up the whole unit?
A little bit. I think it's time to take a nap.
I think it's time for us to take a nap and for you to do the review.